Greetings, welcome to the Brain Gauge channel. This talk is on the cortical metric, or why the brain gauge works. And the cortical metric, is derived from a whole bunch of measures. Basically, when you take a test battery, you get a whole bunch of numbers, and you can evaluate each of those independently, or you can take a look at the cortical metric or the overall score, and see how that does. So, but basically, it's a way to track progress, and it's a much easier way to track progress than looking at individual scores or individual bar charts. So, for example, this is the overall cortical metric that you see here, and that's somebody's timeline. Obviously, zero is not as good as 100, and basically your overall score is also, or your overall cortical metric score is right here. And it is generated from every one of the scores that you've collected, literally every one of them. Now, you might look at this and say, oh, it's just an average of all these scores, and that's really not true. That's not the way it's done. And I'll get to that in a minute. But basically, if you glance at this and you say, okay, well, if you got all these high scores and they're mostly between 94 and 100 and getting 98, that makes sense. But that's really not the way it's done. We use the raw data, and it's not a complete average. So let's look and talk about a little bit more about where it comes from. So you have to think about where the tests come from, and each test has a different mechanism of information processing. And because it does that, each test, because it's different, it's actually a different entity. It's actually a different vector. And so each vector has a different direction, and that vector value is processed in a multivariate analysis. So that's kind of the cool thing. And so when I say multiple vectors, what am I talking about? All right, think about a two-dimensional plot. Everybody understands that, and everybody's seen three-dimensional plots. Now blow your brain up into thinking about 7 or 8 dimensions. So if you have 8 scores from one test battery, then you're going to have 8-dimensional plot, and you're putting your data and you're putting it in that, both that orientation, and you're putting it into that 8-dimensional space. And that's why we make it simplified for you. So anyway, let's take one example just to give you a hint. All these different things, this is sort of representative of your different measures and the different mechanisms. And again, they go into different spatial dimensions in the analysis. And what we're trying to do is generate what we call a CNS profile. So a CNS profile, or central nervous system profile, is really more than just a number. It's sort of where things are. So, and I mentioned, if you have 8 tests, you have 8 dimensions, and that's really, we can't represent that, but we can represent 3 dimensions. And so in this case, we're just going to represent 3 dimensions and in cortical metric space. And so here we have cortical metric space here in this dimensionality. This is basically a sample tracking of just one individual. And what you want to note inside the red circle are the control data. So for all our studies, every study we ever did, and we've had over 100 studies, we've collected control data. And and so it's piled up. But this was just one of the studies, and all the healthy controls were around the 0-0 axis. That's what determines the center point, and that's what you want your CNS profile to move towards. Day 2 of concussion of this one individual was way out here. Day 10 moved in a little closer. 18, 25, it starts moving towards that center goal. So as you get healthier, your scores move back in here. And it may be in a different direction depending on what's wrong. But in this case, that's the way it rolled. Was over to this side. And we won't get into which direction is which. Anyway, but that works pretty well. And so, basically, again, it's combining all the measures into these 3D plots. And this is I used to have a little movie, which was really cool to show you rotating, and that really still didn't get to 8 dimensions. But you can see, differences between 2 populations. They get really distinct because we're using this type of analysis that separates things based on how you did on particular tests. Okay, anyway, in one of the first tests we did, we got like 98% confidence levels in differentiating concussion from non-concussed. And quite frankly, our confidence levels vary from anywhere from in some of these studies from like 89 to 98 or 99, depending on how many tests we do, because every test you do actually increases performance. Now, some of the tests actually might not do that great, but they still contribute. And so some people will come along and say, oh, well, that test only showed a 54% efficacy. Well, that's true. It did, but it improved us from 93 to 97% accuracy. So anyway, when we compares this cortical metric score versus a clinical score, and this is a pretty well accepted clinical score called SCAT, a sports concussion assessment tool, and it's basically just individual reporting of symptoms. And that's, it's not the greatest thing, it's not the most accurate, but it does work. It does have a nice correlation. The problem with that is that you got about, even in the best of places, 8 to 10% of the people will not tell the truth on how many symptoms they have because they want to return to play. That's simple. On this case, remember, smaller numbers are better. If you look at this graph over here, you're saying the smaller numbers are what you're trying to gain. And so that's one reason we call it overall score is to avoid confusion on the brain gauge scoring. And the cortical metric actually does get smaller and smaller with recovery. So this case shows that there's a big difference between history of concussion. People who've had concussions before take much longer to recover. So that's just kind of an interesting thing. Next interesting thing that you want to remember is that the profiles are different between different populations. And so, and no two people are alike. That's the other thing you always got to remember. Any patient or anybody who's had a head injury, no two head injuries are alike. If you've seen one concussion, you've seen one concussion. So how do you take all those things into account, all those factors into account, and then squeeze it down into a few numbers that show some kind of efficacy? This is just showing overall profiles and how they're shaped. And they've been rotated different ways just so you can see them a little better. This is migraines versus controls. And this is concussed versus controls. And actually, concussed and migraine actually are different. And we also looked at, like autism is also very different. So it is in a slightly different dimensional aptitude, so to speak. So that's the kind of fun stuff that we do in research to show all this. But what we've done is we've taken this research and boiled it down into something that is user friendly, like the brain gauge scores that you guys look at. Anyway, how does the brain gauge compare? And this will be the final slide. But ROC analysis is sort of a standard for looking at how well a test does for doing a particular thing. And in this case, we were in a study and we were examining people with concussion and people without. And the perfect score is a right angle. And this is our score, the brain gauge score. It did pretty good. And, basically 1.0 is the best. And that means you made no errors. 50% is the worst. That means you only got that you did the same as flipping a coin. The majority of other measures that we've been compared to are in this gray zone. And I know people get mad when they see this, but it's true. They can't say, no, we were at 63. Okay, you're 63. You're great. You're right above that. But basically, there's a lot of stuff in here that's being used all the time that people shouldn't be using. But anyway, there's a lot of reasons the brain gauge is working really well. But the main number one reason is that we are targeting different mechanisms of information processing, and we're combining them in a very serious multivariate analysis that really, really works very well. Anyway, that's just a quick tutorial, I guess, or talk on the brain gauge metric. And I hope you have a good day and send me some questions anytime.